Oh, first floor. Home. Say hi.
Hi.
So I'm here at the factory in China, and lots of activity going on here. If you've never been to a Chinese factory, it's basically a lot of people doing small individual tasks. Everything from screwdriving to soldering. One common misconception of China is that people think that there's a lot of robots involved, but actually just about everything is made by hand. So it's 10 a.m. here, just a little bit after, and there are lots of people working. It's actually pretty quiet and calm here, which you'd maybe not expect. Everyone's doing different things. This guy's gluing. Some people are waiting around for the production line to catch up. Lots and lots of testing. Lots of storage. And this is other people's stuff, not ours, so I'm not going to bother them. But here's our little test setup line. I'll show you more about what goes into. Yes, in the last video I did say testing, and the reality is that every single part is tested, and everything is tested together, and then it's tested again. So how does stuff come out of China that's broken? Well, lots of reasons. A lot of it has to do with engineering and shipping. There's nothing special about products being made in any country versus another. It's just the same. There's people here that are making products, there's quality control, there's quality assurance, and it's actually all of the same processes. The difference really comes down to engineering, the quality of components, and transferring the knowledge of what the product is actually supposed to do to the factory. That's probably the most important thing, and that's why I'm here. Because the people that are at the factory don't really have the time or energy to think about what the product does and what every little individual feature is meant to do. So the reason I'm here is that I'm the one that has all of the context for how the product works, and they just want to be able to assemble it and make sure that they're checking it to spec. But the spec is something that we have to create together. We have to tell them, okay, no, this bump is too big, this is too small, this is okay. Setting up all the processes actually takes a huge amount of time, and a lot of people are involved. So there's production managers, there's engineers, there's people that are working on the line, there's everyone, up to about 30 or 40 people that are probably at the factory that are touching this project. So there's a lot going on in this factory, but we actually just have a very small area right now where we're doing sort of a test mini production run, just 10 pieces, just to make sure everything is fitting and working together like we expect. So this is just. So the first step in actually manufacturing a Freewrite is what we call the PCBA, printed circuit board assembly. And so this, what I'm holding in my hand, is the printed circuit board with all of the components needed for the actual computer of the Freewrite. So this is the entire computer that's inside of the Freewrite, this right. So once we have the PCB board, we actually use a custom-made piece of equipment. It's called a jig. Inside you'll see tons of little gold pins, and those actually contact all of those little gold dots. So that's a way for us to quickly interface with the board and test every single function. So this board, as it comes off the line, actually goes inside of here and then gets pressed down. And this jig is then connected to a computer where we then run some software to burn the firmware and then also test all the functions. This Freewrite mainboard PCB is actually one of 4 different PCBs inside of the Freewrite. There is also a board that's just for the USB portion. There is one in the keyboard, and there is one for these switches, and each one of them has to be tested separately and individually. At each station, there are work instructions similar to this document that tells the worker exactly what they are supposed to be doing and what to check for. And so right now, it's actually very messy because they're just testing things out, but normally it's a very orderly. Once the firmware has been loaded and tested on the main PCB, it then gets married to an internal piece of structure where all the parts sort of come together. So there's the battery, there's the main board. Here the main board is being installed, and everything is going to be connected up to it. And then once all the things are connected, then this whole assembly gets installed inside of the Freewrite. So just a reminder, this is actually not production. This is just a trial run where each worker is learning what they need to do at each station and just taking their time so that they can do things one by one and make sure that they're doing it right. And then once production actually goes, they don't have to worry about what they're doing. There's a finished module, carefully wrapping and putting away for storage until the next one. Lots to explain. ISO keyboard, ANSI keyboard. Everyone needs to be. Here he's installing the bottom of the case onto the Freewrite using a special jig. Make sure nothing is damaged. Pushing it in very carefully. Checking. So after the base is attached to the bottom, the keyboard is screwed into the body. And there's screws that are hidden underneath these keycaps, so you don't actually see any screws on the finished device. So I'm back from lunch, and I'll show you the quickly. It's a little quiet. They're actually waiting on some parts to come back. There's some rework that needs to be done, but really quickly I wanted to show you. They all wear slippers. How funny is that? So you might be noticing that I have this really cool blue jacket on, and the reason for that is the same thing for the slippers. They actually are designed to prevent electrostatic buildup. That means they don't want to have any kind of static electricity buildup and then could potentially discharge through electrical components and damage them. So he's screwing these in. Each driver has a calibrated torque specific to each screw. That's why there's 3 of them here. So it's been a pretty long day here, and it's just about to be 5 o'clock, which means everybody is going to stop. They just turned off the vacuums, and the lights are about to turn off. And that's... So it's the end of the day. It's about 4:59. And everybody is just waiting for the bell to ring. Oh, and there it goes. Pretty clear what's happening.
Hello.
Hello. Meow.
You like Chinese food?
That's it. This is what always happens when us Westerners want to keep working. They turn off all the lights and literally shut down the factory at 5 p.m. So they don't really give us much choice. There is another overtime shift that eventually comes.